can we just show this? Yeah, or if you have them on your laptop. 0 minutes. If you do your laptop, we'll just stop. Do you want to get this on?
Welcome to Six Man. Let's get started. Welcome, or bonjour, I think is what I'm supposed to start with. Welcome to Montreal. It's a six-man session. We have rehab session today, and we also have a second longer session on Thursday afternoon. Here is the note well, which you should note well. I'm sure we've all memorized this. Oh, wait, we have a problem.
Yeah, this is the problem of if you kick the HDMI converter, it stops working. Just continue, Bob.
Okay. There we go. So now you can note well. We have Barbara and Peng doing Minute Taker and JavaScribe. There's all the links. So going over the agenda, we're doing the intro and document status. We have two working group items. We have area director comments on the SRH draft, which Darren will be going through briefly. We have Tom Herbert's ICMP errors draft, which we'll discuss, which we have the next file with the PathMTU hop-by-hop option, and then we have two individual drafts that Pascal is presenting. And this is the agenda for Thursday, a short introduction, and we have a lot more talks, many of them short. We have the review of the RFC 8200 fragmentation errata. We have discovering Pref 64 and router advertisements. So for today's agenda, this may end up going quicker, so we may move some of the other talks up, but we'll see how it goes. And then we have Ron's, we have a proposal to change RFC 2675 jumbograms to historic. And then we have Ron's SRV6 Plus draft. And we've asked him to basically just not get into the details, but talk about overview and motivation. And then we have a whole bunch of short talks that were new work, and most of them are spring related, that we're going to try to get to both today and Thursday. If we have time, we'll do these. So.
Right, and for the document status, since the last IETF in Prague, no published RFCs, nothing in the RFC editor queue yet, but we managed to get the SRH base document to the IESG, which is on the session coming up just after this. And we have after much deliberation, ended up parking the router advertisement IPv6 only flag. Your comment, Jen?
Yeah, I just want to say that this is really disappointing because now I'm totally confused how we are going to incrementally deploy V6 only networks. So I suggest people who are against it might think about the possible deployment model. Because now when we decided that we do not want to have explicit signal in the network, we might end up with some implicit signal, which is probably not a good idea.
Right. And as I said on the mailing list, I found this call to be difficult to make. Our AD, I was going to say that, come and talk to me and the AD. The AD is at the microphone. So, Suresh, please.
Yeah, Suresh Krishnan. Ola and I talked quite a bit about this. So there's no consensus to advance this. Doesn't mean it's a bad idea or anything, right? So it's just that there's set of compromise to be made because there's quite a bit of operator feedback saying this is actively harmful to them, right? And there's positive points and negative points. It's just that we couldn't find consensus to advance, right? If maybe a year from now things changes, we could bring this back and talk about it, right? Or something materially changes that will change people's minds on this. I know you're disappointed, Jen, but it's the only read of the consensus Ola and I could do on this.
And of course, you can appeal this decision, right? And there's a process of that. But yes, it was certainly hard, and I'm not happy with the outcome either. But that was, where it seemed like the community wanted to go.
Yeah.
Okay. Thank you. Thanks, Suresh. Document status 2. We have 3 working group documents. We have the ICMP errors. It's on the agenda for today. We have the privacy extension update. That's in review. I think we have 2 reviews, and we heard from 1. So I'll follow up that this week and post an update on the mailing list. And then we have the discovering /60 or NAT64 prefixes in router advertisements, which is either on by the end of today or for Thursday. We have 2 ongoing reviews from other working groups. The IP Wave one, I think we're pretty much done with. That's going on in IP Wave. There's been quite a lot of back and forth on that one with regards to prefix lengths and so on. And from 6LO, we just received the IPv6 backbone router document for review. Tim Winters have graciously accepted with a little bit of nudging. I accepted to review that. If there's anyone else who would like to review that document, please raise your hand or let the chairs know. It's reasonably urgently, so we'd like to have a review in a week or 2 for that one. Okay, so the next topic is AD comments on the SRH base document. We have no slides on that, but Darren will bring up the email from our beloved AD. There you are. Let's see if that works. Yeah. Okay.
All right.
Okay. Good morning, afternoon, evening. It's evening now, isn't it? Okay, here we go. All right. So last IETF, we completed our last call. We've gone to review now. Suresh last week, at the end of the week, had come up with his review comments, and we've gone over those. I'm still getting them completed. So what we're going to do is just talk about the issues that Suresh had brought forward. I think that's the right word. And how we're going to resolve those. And at the end of that, if anyone has comments, you're welcome to come up. All right, the first one, and I'm going to read from down here. So TLVs are present when the header extension length exceeds the last entry element in the segments list, and Suresh points out this doesn't sound right. I think we can fix this with a bit of math, describing exactly how an implementation would be able to identify when TLVs are present. So I'll add that in, and that'll go out to the list. Section 2.1, what's the purpose of being able to include an HMAC TLV with the key ID set to 0 since there will be no HMAC? That's been in the draft for quite some time, and I'm going to leave that as to be determined because I have to go back and see what the original intent was around that. Section 2122, where the SRH implementations can support multiple hash functions but must implement SHA-2 in the SHA-256 variant. The belief was that that must level requirement was a little too much. And there's an easy fix here to just qualify that text to say that, well, implementations that do support the HMAC must support this SHA-256. Pasted some old text in here for section 5.3 where there was an ask for more descriptive text around the MTU considerations. And I think what really needs to go in here is just simply stating that the SR source node encapsulates in a packet that's traversing an SR domain. And because of that encapsulation, the edges of the SR domain need to consider MTU. And that text will be sent out to the list, something along those lines. Now, these are our minor comments here. Most of these Suresh has provided text for us, so these will go relatively quickly. There's a comment here saying that RFC 8200 doesn't actually talk about mutability, and we did talk about this within the working group quite a bit. I think the fix here is going to be mentioning that, well, RFC 8200 doesn't explicitly state anything about mutability, that it does allude to it in section 4.4. I think that'll be our resolution to this particular question. I know we had a lot of comment around this text and a lot of work on it in the working group. Go ahead, Suresh, you had other thoughts?
So like my suggested way of going forward with this was saying that based on the constraints specified in section 404 of 8200, like no insertion, right? Mm-hmm. These fields are immutable. So that means that people are not looking for the mutability text in 8200, right. And that should be a good way forward, I think.
Right. Okay, he's offered, oops, let's cancel this here. In section 2.1, I think we should also mention that padding TLVs are used for alignment of TLVs themselves, something along the lines of the new text that was provided. This looks okay to me, and that's obviously the intention of I think padding TLVs is to align the TLVs, so that should be good to go. Section 2.121, what was this one? Text in the beginning is real. Okay, this is in reference to the text in the HMAC field. And I don't have the final text for this yet, but some new text, I shouldn't say text because I'm overusing that word now, a new sentence describing describing this alternate composition without using the word text is what we'll use to fix this particular issue. Section 5.4. The zeroth segment doesn't seem very obvious. Some new text is suggested here, so we'll just take that new text as is. And then on the editorial section, he's got some suggestions around segment routing to be applied to the V6 data plane using a new type of routing extension header. He's got a fix up there, and that text looks fine. And another fix-up in the last comment here as well, just some reordering there, and I don't see anything wrong with that either. Looks pretty straightforward. So once I get the alterations done, we'll send them out to the list and then release a new version of the draft. Thanks, Rash. Go ahead.
So, Suresh Krishnan. So, like, send your fixes to the list and publish a new version, and I'll send it off to IETF last call, and then just follow the process afterwards. Like, look at the directorates and IESG, and hopefully we'll get this done quickly.
Yes, definitely.
Cool. Thanks a lot.
All right, thanks.
Please give me the dongle. I'll give you the. So, Tom Herbert, I think you are up. There you go. See if something happens.
Ready to display?
Mirroring back on again. So your Chromebook down, please. So just see. The chair savvy enthusiasm is limited to powering things back up and down again. That didn't seem to work.
If Meet Echo is listening, could you send the AV people, please?
Shouldn't be very much more than. Doesn't seem to have any reaction also. Does it get out to see? Nothing. Is there I mean, it doesn't show up. Let's see. We'll run it from my laptop. Sorry,
No problem.
should never fill with the AV session. Perhaps you should disable IPv6.
I'm sure there's IPv6 over the HDMI cable. They'll plug you in.
So, well, hang on. So here's that. So we that we used a different laptop on that one, and when we plug it back in again, it doesn't get her from the screen. And we tried rebooting the HDMI inverter.
Try it.
So I have it, the slides up here as well. If
We can try it.
you can, it worked on a Mac.
Uh-oh, so it's not that.
No, because something happened with drag the cable around. Yeah, do that.
It's like a network problem.
Do you want to start talking without the slides?
I can start if you want.
Let's go back to the other one, if that's okay.
Something happens now.
There's one thing here.
Yeah.
Why don't we just go with that?
Yeah. Should we just go with this one now?
Yeah, if you want, so it's just that the problem was that there was a cable that was unplugged down here. So you can transfer this, it should work over here as well.
Okay.
Get rid of this for now.
Okay.
Let's try that.
Just to make sure. And flicker on the screen.
Yeah. Fantastic. Ice cream in the main.
Thank you. Okay, so there must be a good joke in there somewhere, but kind of late in the day, so I won't even try. So I'm going to talk a little bit, hopefully this will be brief, about ICMP v6 errors for discarding packets. This is a working group draft. Just a little bit of overview. So the idea is that we want some ICMP errors that host and middle boxes can send when they drop packets for exceeding limits, particularly in processing extension headers. So this defines 4 new parameter problem codes. It extends applicability of 1 parameter problem code and 1 new destination unreachable code. The parameter problem codes, one, the general parameter problem is used for middle boxes now as opposed to just host. So if a middle box drops a packet for next header unknown, the slide probably wrong, for next header unknown, then the middle box can actually send that message. 4, 5, 6, and 7, the new proposed codes for parameter problems, deal with extension headers. So extension header too big, this can either be number, I think that one's number of bytes, extension header chain too long, so the sum total of extension headers exceeds some processing limit. Too many options in extension header, this is simply a limit of the number of options. And options too big, this is actually a later addition, so a particular option exceeds some limit. So that last one, we also applied to the number of consecutive pads exceeding 7. So we have some two other changes, as I mentioned. We extend the applicability of parameter problem code 1, unrecognized header type, to allow intermediate nodes to send. And we added new destination unreachable code parameter number 8, which is headers too long for applicability of to apply to the situation where the sum total of headers, not just extension headers, may exceed the processing limit of a device. So this might be useful, for instance, in a device that has a parsing header limit, and if that's exceeded, it ends up dropping the packet, so it'd be nice to know that happened. So there's 3 versions of the draft. Suresh, you have a question?
Yeah, I do actually. For Suresh Krishnan. So for the unrecognized next header type, right? Like, are we somehow changing the assumption that intermediate nodes don't look past the unrecognized next headers, because they're only required to look at a few that's different in the RFC, right?
Correct.
And any new extension header types that come after this, like, the intermediate nodes have no business looking at it, at least from like the specification point of view, right?
Yes.
So, and I think, I don't know, like, it's just a point I want to bring it, like, consider this before you put this intermediate nodes to allow to send it, because we are changing something, not just a new ICMP error code, but like how we expect the package to be treated. Does that make sense?
So I think you're saying that this is outside of the bounds of the normal packet processing that these errors are being sent?
Yeah, I think so.
True.
Yeah.
But the problem is devices do this. And
That's
if
fine.
they're dropping
I was
packets, it'd be
sanctioning it.
better to get the information than not get the information. So somehow we're not advocating this behavior, but we're acknowledging it exists. So it would be nice to be informed that they're doing that.
Okay, that's fine. I'm just saying, like, consider it, like, and put some scare text around it, blah, 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 something around it, so which softens it, like saying it's not something we're sanctioning, but we know it happens.
Okay, yes.
But just to be clear here, this is purely in the case where that device has parsed so far into the packet already that it discovers a problem, right? There's no expectation here of a router that doesn't do this to parse this far in so we can send this message back, right?
Yes, so I mean, I think this is explicitly for routers with those limits. And then the question will be, okay, they kick it into a slow path. Does that require ICMP? So there are probably some sub issues, but the error is there for that particular case. So we have 3 drafts. Version 1, I guess 4 drafts. Version 1 was a working group draft. In version 2, and version 2 and 3 are since last IETF. Version 2, we added the last option too big, or last error code, I should say, parameter problem code 7. And in version 3, this was mostly just clarifications in the security section and some edits. Since last IETF, there is an implementation against the Linux code. So a while back in the Linux stack, we did add limits per RFC 8504 for extension headers. So we will drop, for instance, if the number of hop-by-hop options exceeds a limit, that limit happens to be 8 by default. So there's 4 of these errors are actually used in the implementation so far. The first 2 are basically syscuddles, and those have to do with, as I said, the RFC 8504 limits. The third case there, extension header too big. So this is applied in 2 cases. One is normal extension header exceeding a byte limit, but it's also convenient if padding exceeds the number of pads. So RFC 8504, for instance, recommends that, or suggests there could be a limit of 7 consecutive padding bytes. If that's exceeded, the Linux stack at least will drop the packet. So now we send the extension header too big message. So when I posted this upstream, we got some good feedback from the NetDev maintainer. He commented that there were other cases in this particular block of code where we're parsing extension headers, where we were dropping packets and not sending ICMP errors. So we filled that out. In particular, one of the things that Linux does, it does check pad-n data bytes to make sure they're 0. So if they're not 0, we now send just a normal header field parameter problem. The feedback was basically pretty straightforward. We really can't take this into upstream Linux without the formal IANA assignments. So a little bit of a chicken and egg problem there. Suresh.
Yeah, Suresh Krishnan. So, like, one thing we can do, if the chairs, like, do a consensus call on the list, asking for an early allocation, we can actually go and get an allocation right now, right? And then it expires in some amount of time, like, I don't know, 9 months or like a year or something. So you can get the code points, log them down, and put them in the implementations, and the draft can progress in parallel. So that's like a mechanism I'm offering to you. Like, the chairs just have to request me.
Okay, so just request the assignment without
it's
worrying about the status
request.
of it.
We've done a few of them before. So just ask for early allocation to the chairs. They do a call, and then we go forward.
Okay. Do you see any, foresee any issues asking for, I think we're asking for 4 new codes, 5 new codes actually. Okay. Great. This question I have is this ready for working group last call, or what else do we need?
Don't all run to your microphones. How many people would be willing to review this as a part of a working group last call? 1, 2, 3, 4, 5, 6. Fantastic. I didn't need my threat, which I'd planned out to say. Excellent. I do remember you, so this will come back to you. Yes, I think we're ready to last call this, and we'll send that announcement out as soon as we can.
All right. Thank you.
Thank you, Tom. Okay, the next one is Bob and Gori, I think. Are you both going in the pink box?
Yes, so. Just be quick.
So it's only a pink X this time, no box. So
Hi, I'm Gary.
I'm Bob. So just as a summary, as you all know, PathMTU discovery doesn't work too well on the internet. We came up with this idea that it might be more reliable for the destination to send the feedback back to the source. There's a better trust relationship. But we understand this may not work in all places, and this is sort of what we're trying to find out. Changes in the current draft, we changed the option format to include the return value and a return flag. And I think we talked about, we tried this out in the previous hackathon, but we moved the flag to the least low order bit in the last 2 bytes. And we're no longer, because we have a return value, we're no longer using the ICMP packet to big messages. We're just, you send this in another hop-by-hop option back to the source, or you send your own, you can include this. And so there are a lot of text changes relating to this. We also added acknowledgement section that there was a similar mechanism proposed in 1988 for IPv4 that was didn't go too far because they abandoned it with the current IPv4 PathMTU discovery. Had they only known that we wouldn't be doing this today, and a bunch of editorial changes. So, and here's the new formats. I'm sure you've all read the draft, but you can see the return flag at the end, and we named the fields instead of value 1 and value 2. So this is what's in the current draft.
So we've implemented it, and we have something in Wireshark that works. But we need to work out if it actually works to the internet, which seems like the most important question. So we need people to do experiments. We plan to do experiments. The first one is, do hop-by-hop options really work? We really hope so. What size of PathMTU is actually supported, and where are the MTU bottlenecks? And we don't know the answers to this, so that's why we're building the tool, but we need to do a bit of mapping for this. And what happens in practice when we try and do this when we have the crazy real internet? Well, we're going to do this work, and we would love other people to join us. So it's a plea for other people to say this is fun.
Oh, and so we had a smaller hackathon project. Oli worked on his VPP router implementation, and I learned how to actually, instead of doing a Lua plugin, I learned with a lot of help how to actually modify Wireshark, change the packet-ipv6.c file. And with some other help, we finally have it working, as you can maybe read this, but it now shows the option. And more importantly, with the thing we couldn't do with the Lua plugin, it actually shows correctly what's after this header, which the previous one didn't do. So at least that's working. And unfortunately, I know a little bit about Wireshark now. We want to continue the experiments. We're looking for other people to help with this. I've heard that someone is going to have some boxes that you can deploy. And we would like the working group to adopt this. It's currently labeled as experimental, but I think we can still do that. And if there's interest, we would like to ask the AD so we can do an early IANA allocation. And the reason for this is we want to do internet-wide experimentation. The experimental values are just fine for doing it on the table in hackathon, but to run it over the internet, I think we really need code points that won't conflict with other experiments. So we would like to do both of these things. So questions, comments?
Hi, my name is Tim Shepard. Sometimes the MTU bottleneck is in a box that does not look at the IP header. And in which case, the box that is looking at the IP header and the extension headers might not even know about an MTU bottleneck between it and its next top IP layer thing. And so so just as long as you all understand the limitation of this.
There's an easy answer to this, yes. But, okay, so there's two places where you could use this. One was in an area where you're actually configuring equipment and you intend it all to work and you've just got different MTUs. Then it probably will work. In the big bad internet, maybe you need to couple it with something magic like DPLP MTUD or PMTUD or something to discover all these other facets. But it still helps.
Yeah, I just to add to that, I mean, we're not expecting this to be the magic bullet that makes this perfect. We think we're trying to figure out if this is a useful tool that will help, the transport will need to fall back to whatever information it can obtain, whether it's stuff it figures out or whether it gets feedback like this, or, nodes that don't support this may still do, send ICMP packet to big messages. All of that feedback needs to be dealt with.
Tom Herbert. So I really love the kind of hidden bullet point there that we were going to do some experiments to see if extension headers work over the internet again. Be fantastic if we could have fresher data than RFC. I think it's 78, 72. And not only that, if you do this experiment, and I certainly would volunteer to help, can we make this kind of ongoing to measure the progression of or the deployment of extension headers? Just hopefully the situation's improving, but right now without data, obviously we're in the dark on it.
The answer to that's probably all yes, but it'd be really good to have some useful headers. And here's an example of a potentially useful header.
I think
Jen was next.
Yes, she is.
Jen Linkova, someone who actually promised to get you data, and I'm working on it. I'm in the middle of the experiment, so yeah, we'll get some additional measurements on extension headers. And so I like this. Again, how useful it is, we'll see after we do some measurements, right? It's really early to say if you actually can do it internet scale, yeah, but I support this idea, and I think, yeah, we need to run internet-wide. Like, actually get in, I don't know, is Robert here? Can we get when we get an option, can we get RIPE Atlas to support this? It might help with measurement, but we definitely can try something. Oh, measurement.
Joel Yeagley. So I like the idea of experimentation. I would like to see if, in fact, there are some places on the internet that you can pass hop-by-hop options through. I know in the case of my network that because those actually have to be sent up to the control plane, I will never see them because I can't process them. So I know how that experiment is going to go. But maybe it's possible to build a router architecture that can actually do that these days. I'm not sure someone's going to write a P4 specifically to process a hop-by-hop option and use 500 million transistors to help make ICMP forward better, but maybe they will. I don't know.
Well, I mean, the part of the motivation, Joel, so part of the motivation for this is in environments where you can have links with larger MTUs to actually be able to use them, and we're hoping that that might be enough incentive.
Well, I could use a link MTU of 16K right now, but I don't really think I can forward packets up to my control plane at 400 gigabit rates for possibly obvious reasons.
Jeff
Houston, AP. We've done a fair deal of this measurement using a combination of Google's online ads to get a massive number of insights, all forwarding back to a small number of servers. And this is a TCP conversation, so the servers basically send out mangled packets and look for the ACK. We did this a few 100 million times, November last year. The ACK rate was bad. We're getting a failure rate of these kind of packets of between 30 and 36%. So it's pretty gloomy out there. There's an awful lot of dropping of extension headers. I've no idea why. we are looking at doing this on an ongoing basis for both UDP, for the DNS and TCP, and we'll put up a page or something and sort of publish it more regularly. But, you know, the base level data is, for whatever reason, deployed B6 equipment out there on transit links seems to be very extension header hostile.
Dave Taylor. So let's assume for the sake of argument right now that you have a path that does not drop packets with hop-by-hop options, things go through, right? My understanding of what your draft talks about is that if you don't understand it, you just pass it on, right? And so this actually does not discover the path MTU. This discovers an upper bound on it, right? Because the hidden node may have something lower, right? So it gives you an upper bound on the path MTU.
Sure.
Right? Correct?
It only works as a hint.
Yeah, right.
It provides you an immediate hint of a big MTU.
So it provides a hint at the path MTU in the same sense as your local view of your current link MTU does, right? Which is it's an upper bound, right? Now you observed at the beginning that PMTUD has problems across the internet, and yeah, you can get this information. What are you going to use it for?
We have a routine in DPL PMTUD which takes PTB processing. This is an even easier one to include as a hook.
So it's a hint for use in PL MTUD. Yes?
PL PMTUD.
The packetization layer MTUD. It's a hint for this. So it's an optimization for that, right? I just want to caution you can't actually rely on this and use it as a path MTU because it's not. It's just an upper bound. Yeah.
Sure, because it doesn't check Ethernet switches on the way either in the middle.
Eric Klein, quick question. The RFC, was this 2464? I think IPv6 over Ethernet basically says if it's 1500, if it's greater than 1500, it should be ignored and logged. There's an exception for manual whatever, of course. Do we want to like update that as well at some point?
Oh, yeah.
Okay. I'd be in favor of
Though I think IEEE also sort of says something like that too, and somehow people manage to do it.
I mean, I don't know what happens if I say 9K in an MTU and do like, does it properly get ignored or does it properly get honored? In an RA, not necessarily. I mean, if you have manually configured that works based on the driver, I guess. But yeah.
Okay, so I think I want to do a hum to see if there's interest in adopting this. So can the people who are in favor of making this a working group document please hum now? And those who are violently against, please hum as loud as you can now. And those who rather want to go to the social and didn't pay attention can hum now.
That's right.
That was the loudest, yeah. Okay, I heard, there's some interest for this. We'll confirm that on the mailing list. Okay, excellent. I think, Pascal, you are up next.
Which time?
You have 10 minutes on the agenda, but we have a little bit extra, and because I don't think we will have time for the extra talks we tried to slot in. Now, so you have the rest of so you have 17 minutes.
Oh,
so these are two lightning talks that Pascal will introduce that comes from, mostly from 6LoW, right?
Well, this draft's actually triggered by work at IPWave and working with the IPF guys as INT, DIR reviewer and IETF reviewer. I realized that we kind of needed a common framework to understand how we can map IPv6 over radios so that people coming in with a particular radio could actually refer to that, because there was a lot of ingenuity, I'd say, in the way they approach the problem. So I thought, hey, I could write a paper just specific to IPWave, or I could just try to see if 6man as a whole can agree on the various models that we could apply to IPv6 over wireless. So I ended up with this draft. Next slide. Okay, so I don't have much time. I presented that at 6LoW, many more slides. So I just picked 3. That's the chairs required. And so it's 3 different angles of the same problem. This slide is all about The expectation that people doing wireless would have on an IPv6 neighbor discovery method. And, well, there is quite a mismatch. So the first point which really hurts is that usually for most radios, the medium is not transitive. It is usually reflexive, though not necessarily. Like if A can talk to B, usually B can talk to I. It's not necessarily true, right? You have difference of power, you've got interference on one side, you've got lots of effects that may make it so it's not reflexive. But most of the time it is. What it is not is transitive. Like if you have ABC in this picture, you get the broadcast domain of ABC. A can talk to B, B can talk to C, but A cannot talk to C. So if there is a DAD message or a lookup and it's just broadcasted by A on its broadcast domain, then C will not be able to respond. So that's the basic thing which appears on most of the radios around, with the exception of Wi-Fi, because Wi-Fi provides a MAC level emulation of a broadcast domain by using the broadcast domain of the AP as the reference. But even if you're there, ND again fails to be filling all its promises, and in particular, it hurts a lot because of the broadcast that it generates. We've done measures recently. There was the Cisco Live like a month ago, and there was this big room for the keynote. It was very well attended, thank you. And we kind of measured the network for the hour and a half of the keynote and found that IPv6 ND generated 300 messages per second during the whole show, average. 300 message per second broadcast over the whole thing during 1 hour and a half. Think about the battery of your device during that time. Okay, and that could have been completely avoided if we add the method that we have deployed at 6LoW, by the way. And then there are a number of other mismatches that appear. For instance, there was a great effort at 802.11 called FILS, 802.11 AI, which is kind of the Tokyo Station use case where you've got 300 people going out of train in the station. They want instant connectivity, and there was a lot of effort at .11 to give them almost instant connectivity, log them all, etc., give them access. And then if you've read Jen's draft, you realize that within a number of seconds, a good number of them still don't get IPv6 connectivity. Hopefully they do IPv4, but for IPv6, it's another game. So this is just one example, but there's also all the sensitivity to DOS attacks, etc. So ND is not historic, but it is certainly archaic. So that's one angle, applying just ND to most of the radios around. Now, this draft is not specifically about ND. It's about more like what kind of models do we want to apply? Where's the link? Where's subnet? What kind of subnet do you want to build? Is the subnet bigger than the link? Is the link bigger than the subnet? Is it a multi-link subnet? All those games. So we try to model that and just give a name to the different approaches. An interesting one is what is your link, right? IPv6 says the link is the medium for communication between two devices. Well, that's fine. What do you mean by medium? Is it a layer 2 medium? Is it a layer 1 medium? If you look at your layer 1 medium, that's my broadcast domain. On my broadcast domain, I can talk, but I mean, who can I talk to? Can I establish a point-to-point link, right? If I do that, if I start my radio in the morning and I do that on an IPv6 link local address and I walk all day with my radio on, do I consider that the DAD I did in the morning is still valid 2 hours later when I crossed half of the world? Probably not. So you realize that a domain on which I can assert the uniqueness of my link local address is probably a peer that I'm talking to at the link layer, meaning that a link is probably a pair of devices communicating with one another that when they start assert that each other's address is unique from each other's perspective. And that's how 6LoW modeled actually the radio domain. Doesn't mean that the subnet is that. For instance, here I just have one of the possible model, which is hub and spoke, whereby the router in the middle can use the same prefix to talk, prefix B, column 64, can be used for A and C to form addresses, and they can all talk together as long as B exposes the prefix as not on link and relays packet between A and C. So the model that you're used to in BSS, which is the Wi-Fi equivalent of this, can completely apply in exactly the same fashion at layer 3. If you don't have a layer 2 BSS, we can do it at layer 3, thank you. Exactly the same model. And that's what we did at 6LoW. We just reproduced what is known to work well in .11 at infrastructure mode, and we just replicated that at layer 3. Last but not least angle of this discussion is Can we do everything that we want already with the method we have at layer 3? Not exactly. There are, even for IP wave, even based on everything we have at 6LoW, there are still things which could be improved. 6LoW mostly considered devices that don't really move a lot. And well, I did code that in our routers like 15 years ago, realized that if I had to tweak ND to get a mobile router to work. And the reason is, for instance, ND doesn't tell you if you have to match the prefix. Well, it tells you don't. Have to match the prefix that the router gives away and the source address that you use. So if you're moving with your radio on and you get arrays as you go, and you form addresses with all those prefixes that you hear as you go, and then you use any of the addresses that you formed with any of the routers that you've heard about, there's a good chance that the router that you use is gone or doesn't know the prefix that you're using and will filter it out. So if you're mobile and you don't even have a link layer method to detect the routers you have around, which is the case of OCB for .11, then you probably want to have new things that you do, including matching the address with the router. I get this PIO from that router, I'm using this source address, I'm using that router. It's unusual for ND, it's not the right thing maybe in some environments. It's pretty much the thing you have to do if you do IP mobile IP. And part of that game is also how you manage your default router list. Because maybe this router uses the array interval and speaks every 100 milliseconds with a new array. That's very good as a layer 3 beacon. That's how you do the .11 beacon. But this other router speaks every minute, but I just heard about it. So which one should I use? The one that speaks every minute that I just heard, or the one that tells me it's going to beacon every 100 milliseconds? That's a sort of logic that you have to invent as you go. And I did my own, like in our routers long ago when I did those experiments. But there is no standard for doing this, and probably did the wrong thing. It appeared to work. But if we want to enable mobile things like those cars of our OCB, then we'll have to reconsider those things. So the array interval that we have in mobile IP is the beginning of that story that emulates the beacon. But then how you manage your care of address and match it with the router, this is not described anywhere. So that's pretty much what I had on this slide. So if you want more slides, I present them in 6LoW, just download them from 6LoW. If you want more time next time, I can go on all the subnet models and discuss that. Otherwise, there's a draft. But the question to the room is there interest in 6man to document all those possibilities and those things, right? The draft is published. I can leave it like that. I can extend it. There are tons of things I could write in there. Is there interest?
So, I mean, in the past, we have worked on, ND DAD issues. We had the efficient ND work, which did strand, but I do wonder if the world has moved on that.
This one is more. It's not on a track. It's more informational. Like, here are things, right? Here is how you could play with your radio. Right. Here is how you could map ND. With traditional ND, you can do this. With 6LoW and ND, you can do that. And here is what you still cannot do, kind of. It's more this level. If you want to solve anything, I don't expect it to be this draft.
Right. No, so I wanted to see if is there some interest in restarting work in this area? Lorenzo?
Lorenzo Clivy, I've read the draft for once. This draft is sort of like not even almost about restarting work. I think it's there's a good summary of things that have been done in the past and in different link layers and what the underlying semantics of the links are and what you can do with them. It's heavily biased towards what was done already. And it's sort of a little bit biased against like classic ND. There's a few sort of like, we recommend this and we recommend that, which doesn't really belong in informational. But I think as a document itself is actually useful because it presents, it's relatively neutral and it presents like a lot of the trade-offs that were made. But I don't know that it's something that we need to work on. It's sort of like, it's almost complete as is, right? I wonder if it just should be, published as an IC or something. It's a useful document for sure, but I don't think that it's kicking off work it seems like mostly complete already.
I hope it's going to help the work at IPWave because that was the initial goal, but I thought publishing it at IPWave was too limited. No point of doing that.
Yeah, and I mean, this is just to introduce the work and we'll continue on the mailing list. Yep. one more.
So this one is not a 6-man draft, but I don't know where it should live. Actually, we asked the question at 6low, and the sense of the room and of the AD, if I remember well, was that it would be better at 6-man than 6low. So this is the logical continuation of the work that happened at 6low. The work that happened at 6low was really looking at the wireless side, trying to optimize the multicast. But we realized that probably there are some of those aspects that we could actually port into a more general usage. So what do we try to address here? The first thing we try to address is the scalability of an IPv6 subnet. And if you rely on MAC-level emulation of a broadcast domain over a large fabric, well, that's fine on a limited Ethernet switch fabric. If you have a lot of wireless edge, it already starts to work. If you distribute your layer 2 fabric over layer 3 in multiple data centers, that really hurts a lot. What we do in those networks is we build overlays, and we want to resolve the other end of the tunnel. We don't want to have to broadcast anything. It happens that today with our COM fabrics, we still do have to do broadcasts because there are cases where we don't resolve, and that really hurts. So what we would like to do is do all our resolution through a mapping server, most of them in pure unicast, and avoid the broadcast. So today, my company sells solution based on Lisp to do that. So we have this map server, my resolver, and you can query it with Lisp. And if you do that, then you can save a lookup. You can save a broadcast on your fabric. But what we don't have is a generic way of doing that through the most logical way, which is neighbor discovery. So the idea behind this draft is pretty much to say, hey, we already have this in 6low, this central registrar where we list all the addresses in the network that were registered. That's how we do that over multiple routers in a big fabric. Why don't we just look at this thing using the same ND methods? So you could use, so the draft proposes just an NS lookup, but you send it to unicast to this guy. It's the first thing you can do. Or if it's actually not on your broadcast link, like if you're on a wireless Wi-Fi and we do this backbone router game and the proxy, which is actually recommended by Wi-Fi, then you will have a packet that goes multiple hops because you have to go to the router and it's different links. You have a backbone link, which is represented on the right here by this Ethernet backbone, and you have the wireless link, and there are two different links, like it's an heterogeneous multi-link subnet. So if you live in a world like this, then the database is not on your link. It's on the broadcast domain, on the Ethernet, meaning that you need a packet which goes multiple hops, which is what 6low has provided anyway. So what the draft does mostly is take the 6low signaling, which can go multiple hop, which is called DARDAC, duplicate address request, duplicate address confirm, and extend it to do a lookup. So now we have a new code. It's semi-CMP code, right? We don't semi-CMP type. We don't go use a new ICMP type, but we have code and subcode in there. And so we just take in that space and allow this multi-hop message to be a lookup as opposed to just a DAD request. That's pretty much what the message does. 2 minutes? Okay, one on this slide, one on the next. So this is just giving you an example. So all the 6low drafts, basically, which talk about the backbone are really meant to coexist. It doesn't mean that you have to have either the broadcast games, the old ND or 6low ND. You can have both at the same time. It's really meant to coexist. Now here is what would happen in the FILS use case, 802.11ai, where all those hundreds of people jump out of the train. So any of those guys would basically send an RS to locate the router. It's supposed to be a multicast, but since the access point is a router, and the access point is the one that does the real broadcast, it just will not do that because it's a router. So it will just intercept the RS, and the RS will never be broadcasted on the wireless network. Then it will answer unicast array, so that's immediate. And now the 6LN can autoconf an address as many as it likes, and it registers them to the 6LBR, which means that we pre-populate the ND cache. That's the important thing, right? We pre-populate the ND cache. So now, if there is this is the registration. So you register to the router, the register writes it down on the central registry, and now we can do optimistic DAD pretty much. That's what's happening here. So the host sent, well, on behalf, because there's a proxy, send an RS to the router without SLAO because that's ODAD. The router wants to answer unicast, so it sends an NS-NA, and that's how the router gets populated. And now in optimistic mode, the IPv6 packets can start right over. So you don't have any delay, just a few exchanges, and there you go. You can start exchanging your data. So that's pretty much what we can do in IPv6 to finish what the .11ai group started at 8.2.11. And that's pretty much my talk. So we put the central registrar that we already have anyway. We give an ND interface to it so that any host can register to it. And the most hosts register to it, the less broadcast you will get doing lookup. That's pretty much what you have.
Super. Thank you, Pascal. And the blue sheets, please. And we're done for today, but we'll reconvene on Thursday afternoon in the neighboring room. I hope to see you all there. Yes, but please follow up on the mailing list. We're out of time, so.